Okay, so the second part of 3-2, solving systems of equations algebraically. Today we'll be talking about the elimination method. Eliminate means to get rid of. So we will be getting rid of one of the variables in the system of equations by adding. It says subtracting, but we will not be doing that because there's more chances for errors with double negatives and such. So we're just going to add. So use the elimination method to solve the system of equations right here. So since the coefficients of the x terms, 6x and negative 6x, are additive inverses, that means one is a positive, one's a negative, and the coefficient is the same, you can eliminate the x terms by adding the two equations together. Let's give that a try. So here's our two equations. We're going to try adding them together. And when we do that, the x's cancel. We have eliminated the variable. And we have 8y plus y, so that's 9y. And 32 plus 31 is 63. Now, we still are going to try and get that y by itself. So we divide both sides by 9. And we find y is 7. We're halfway done. Much quicker in cases like this than getting the y all by itself and putting it up here by the 8, like we did in 3-2 part 1. I'll put a card up here so that you can refresh your memory with that video. So now that we have found y, we'll find x by substituting 7 for y in either one of these original equations. We chose the top one because it's on top. So we put the 7 in for the y, then we multiply it out, then we subtract 56 from both sides to get the x all by itself, then we divide by 6, and we get x is negative 4. We have completed the second part. Now, the solution is, what we need to do here is write an ordered pair, because anytime you're solving a system of equations, you need an ordered pair. So the solution is negative 4, 7. And remember, that goes in alphabetical order, x, then y. So some systems of equations can't be solved just by adding, or if you subtract by subtracting. But I don't recommend subtracting. In such cases, one or both equations must first be multiplied by a number before the system can be solved. So let's look at these two equations. If we were to add them together, we get 8x minus 5y equals 31. We would still have both our variables. So we need to eliminate one of these variables, and before we do that, we have to multiply either one line by a number or one line by a number and the other line by a different number. So can 3 go into 5 or 5 go into 3? Like, can we multiply one line? No. Can we multiply 2 by something to have it equal 7 or 7 by something to have it equal 2? No. So we're going to have to multiply each line by a different number. And which variable would be easiest to get rid of, the x's or the y's? Well, let's look at the y's here. We have a negative and a positive, so that when we add together, we have the chance, if we can get these numbers, these coefficients to be the same, that the variable will eliminate. Whereas these, we'd also have to multiply by a negative. And that just opens a whole new can of worms. So let's look at the y's. To eliminate the y variables, we can multiply the first equation by what, and the second equation by something else. Well, we have a negative and a positive, so that's important. That reinforces that we want the y's. if we multiply the first equation by 2 and the second equation by 7, then we have to get the same number here, right? 2 times -7 is -14. 7 times +2 is 14. They would cancel each other or eliminate. So let's go to the next page here. Okay, so we're going to multiply the entire equation by 2. Don't forget to multiply this last part. And then we're going to take this second equation and multiply the whole second equation by 7. And you can see now we have -14 and +14. You can always do this, multiply by the other coefficient to get the same number. Although I have to warn you, sometimes your numbers will get really big with that, but sometimes you don't have any other choice. So now we have two equations with additive inverses for coefficients for one of the variables. So we're going to add the two equations together. Get 6x plus 35x is 41x. -28 plus 315 is 287, and the y's cancel. Then we are looking for what x is, so we're multiplying x by 41. We divide, and we get x is 7. We're halfway done. Now we're going to find y, because we already found x, by substituting 7 in for x and then in the original equation, and I think this is the top one originally. So we substitute in the 7, multiply it through, then we're looking to get y by itself, so we subtract the 21, and then we divide by -7, and we get +5. Now don't forget, your answer has to be an ordered pair in alphabetical order. There you go. It's 7, 5 is your answer. Okay, if you add or subtract two equations in the system and the result is an equation that is never true, then the system is inconsistent and it has no solution. If the result when you add or subtract two equations in a system is an equation that is always true, then the system is dependent and has infinitely many solutions. So let's look at these two problems here. What are the solutions to the following systems? So we're adding together here. We have -3x and 3x. That makes 0. Y and -y also cancels. And 5 and -5 cancel, so we get 0 equals 0. Is this true? Well, yes. Yes, it is. Elimination gives an equation that is always true. The two equations in the system represent the same line. This is a dependent system with infinitely many solutions. So if you equal the 0 equals 0, you have a true statement. You have infinitely many solutions. Now let's try with these two systems. We get 0, 0, and then 6 plus 10 is 16. Does 0 equal 16? Of course it doesn't. So elimination gives an equation that is always false. The two equations in the system represent parallel lines. This is an inconsistent solution. It has no solutions. So if you answer no to is this a true statement, then there are no solutions. That's it for today. Hope you have a great day.